what the other classes are right now.
We got
So
more time.
yeah, we'll have time. Yeah, yeah, we'll have time. I don't know. We'll see. I mean, you guys are usually pretty good. Maybe 20 minutes, hopefully. Yeah, maybe more. All right. So Fern states if a triangle is equilateral, then all angles have equal measure and must be a regular polygon. Does this reasoning work for polygons with more than three sides? Okay. So again, all angles have equal measure. It must be a regular polygon. So part A, if all the sides of polygons such as quadrilateral are equal, does that mean that the angles must be equal? So we need to come up with a counterexample if the answer is no. And the answer is no. What's your counterexample? So all the sides are the same. If all the sides are equal, all sides are equal, then would the angles all be equal? Now, for square, that'd be true, but what shape would not? Go ahead, say it. No, no, four side shape. That where all sides are the same, but not all the angles are the same. You guys remember? Rhombus, yeah, rhombus, yeah. I thought I heard rhombus, but yeah, rhombus, right. So square, well, actually, I don't want to draw a square. That's because we're trying to say no. That's a crappy looking rhombus. A rhombus would be my counterexample because all these sides are the same, but not all the angles. So you could assume that for a triangle, but not for a four-sided shape. Now, what if all angles are equal? Does that force a polygon to be equilateral? No, again. So give me an example where of a quadrilateral where all four angles are the same, but not all four sides. A rectangle, perfect. Thank you. Yes, a rectangle. Because a rectangle, all four angles are the same. Okay. So yeah. Anyway, just something to think about. So when we get to regular polygons, we have to have both things happening. All sides the same and all angles have to be the same. That's the whole point of this exercise. So why do we didn't have this exercise just for fun. What was the intent of this exercise? So exercise 825 pretty much proves that we must have both of these conditions true to have a regular polygon. And those are going to be all angles are equal, all sides are equal. One is not good enough. You need both to be a regular polygon. So that's really what the whole intention of this exercise is telling us. So these are good annotations. And by the way, all these are recorded, right? I've recorded all these. So this will help you prepare for our next test on this, which I don't know when the heck that's going to be, sometime in March, but um, you know, it helps you kind of understand the stuff, right? Now let's look at 826. So let's have someone read. Adam, because I'm looking at you.
Yeah.
Can you read 826, please? Okay.
Yeah. What about experience? What we learned about them? Examine the regular hexagon shown in red. The hammer is example next to it, forming the outside of the hexagon by extending the eight sides. Are all the exterior angles for regular polygons? Explain anything.
So good, thank you. And so the answer is going to be yes for that one. And here's what's happening. Um, since all interior angles are congruent, then the exterior angles are congruent. And that's because we'll call this B here. What's B plus A going to add up to? If B is right next to A and they form a line. Yeah, always. And by the way, if that's B, aren't all these also called B? Sorry, that's a crappy looking B over there. So if that's true, then all these have to be A. So all the exterior angles would have to be the same then. So let's actually find it for this one here. So if I actually find it for this one, you guys remember the formula we had to find the sum of all the angles? You guys forgot already, Rick?
-2.
Yeah, remember it was 180 n minus 360. Remember we solved that and that became 180 n minus 2? Or I don't know how to do y. We use s for the sum. So the sum of all the angles is 180 n minus 360. So how many sides do I have right now? So 180 times 4, which is what? What's 18 times 4? Or 18 times 2 twice. 18 times 2 once is 36. Well, 36 times 36. Sorry, 36 plus 36. Yeah, 720. Yeah. It's okay. So 720. However, we're not out of the woods yet. 720 is the sum of all the angles inside. How do I get each interior angle? How many angles am I talking about here? So you get 120. And 120 is this one. Does that make sense how that's 120? So what's A going to be then? 60. Perfect. So A has to be 60 degrees. Now, if you think about it, how many exterior angles do I have? 1, 2, 3. How many total? 6. So 6 times 60 is what? 360. So this will be an interesting observation. Let's now look at other shapes and let's figure out what's going on with the exterior angles there. And we should be able to make a conjecture very shortly. Okay. So it says here with your team, blah, blah, blah. Well, I think you guys could figure that. I think I'll just kind of tell what's going on. So let's draw these shapes here. I'm not going to draw a dodecagon. I can handle an octagon though. Okay. So if I look at equal out triangle, what's the measure of each of these angles here on the inside? Yeah, because you have to split 180 three ways. So if I were to extend one of the sides, I know I didn't draw it to scale. How long would this angle be then? Or how large would that be? 120, good. So if I do 180 minus 60, I get 120. And how many exterior angles do I have for a triangle? It's like a little like ninja star. So it'll be 120 times 3, which of course is 360. Interesting. Because we got 360 for the hexagon. Again, 360 for the triangle. Okay. Mind you, we're looking at exterior angles, not interior. Interior to help us get exterior, but we're looking at exterior ultimately. Okay, octagon. A few ways you could look at it. We could do this whole n minus 2 times 180 bit. So you have eight angles, 8 sides. And you have to divide that by 8. I'm just going to tell you right now, it's 135, just to save you the trouble. So this angle right here is 135 degrees. Now let's extend that side. If I extend it, how large is this angle then? That's right next to it. What do you guys think? Go ahead, say it. You got it.
You got it, brother.
45. See, yeah, you got it. There you go. You got to step up to the plate and swing away, dude. Using a baseball analogy. Are you a pitcher or a batter? Or both? Batter, okay. 45 degrees. There we go. So 45 degrees, right? Now, if I do 45 times 8, that's still 360. I still get 360. So you can keep doing this. You're going to get the same conclusion every single time. Julia, go ahead. Yeah, we will do that eventually. Correct. We will to get the exterior angles. Yeah, but we first need to discover that they all have the 360 first before we do that approach. So every single time, if I find the interior angles, so for decagon, you can look up your notes. The exterior angle is 140. Sorry, the interior angle is 144. For dodecagon, the interior angle is 150.
You just divide like the middle side that.
Yeah, Joyce just said the same thing. Right. She just said the same thing. Right.
We would get points off.
No, I want you to do that. I just need to show you why it works. I want you to. Hey, guys, let's focus, please. Thank you. I know it's the end of the day, but let's focus. Let's finish strong today. Yeah, if you multiply it out, you can get 360 again, 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 and again. Okay, cool so far? All right. We'll look at E, and then I'm going to have you try F on your own. Then we'll actually, I'll do E and F with you guys, and then I'm going to have you guys do page 14 on your own. All right, so let's take a look at E. So compare results, blah, blah, blah. What's a conjecture? So what conclusion can we draw from this, right? That's the whole point. What conclusion can we draw? Here's the conclusion. The sum of all exterior angles of a polygon is equal to 360 degrees. That's it. So to your point, Nick, and Juliet's point, like, yeah, ultimately now you know, just divide it by the number of sides or angles and you get the measure of each exterior angle. And it says here, confirm your conjecture for each polygon. Start by tracing one exterior angle from tracing paper. Actually, we don't need to do that. That's okay. And it says to and then we have to measure it, or what do we have to do? Then you move to place it up. Yeah, it's fine. Let's not worry about it. I think you guys get the idea. Okay, here's what I want you guys to do. Let's go to 827. And I want you to work on these problems in your table groups. And we'll check in about 5 minutes. Okay. After that, then we could do a little bit of page 15 because the other class did that, and then you guys could work on homework. But go and try 827 on your own. I'll walk around, see how you guys are doing. And I'll put up the answer key also.
Another coach from Columbia put me in the AD up there, so I only use that.
Yeah. So set equal to the formula, which is 180 parentheses n minus 2. So yeah, divide by 180 and then add 2. We're correct. Because now you go in reverse.
Wait, can you say like 9 gods?
Yeah, sure. Or nonagon.
Bro, my calculator is up. I can't. My calculator is broken.
Question. I think. Um,
Yeah, what's up?
so
That just square.
it says the cardinal reverse person that's 9 divided through 60 divided by 4.
What is the measure of what's infused in?
So you get 90, right?
Is that the number?
Yeah, that's it. Yeah, that's it. Yeah, yeah.
What is regular 360 gone?
One? Yeah. One.
Oh, I knew, I know.
Yeah.
That shit with like more, yeah.
Do you know what D is?
What do you think? What? Like a shit.
Yeah, but it says a regular.
You want us to do
360 gone, I don't know what's gone.
Oh, yeah, go all the way to the end. I'll walk around in a moment, guys. Hold on.
You know, that's right, yeah.
Is this
It's a 9 gone.
First one done.
What was that? Sorry?
Somebody
360.
You thousand touch you. 2,000 something. How many sides? So there.
I think. What?
I was in April 2005.
Yeah.
First minute I.
It's not, no.
Angel saw my.
Sure, it's not that time.
Very, very young Tuesday. You guys really want.
Yeah. Sorry for
What do they mean by regular? Oh, 306. Yeah. Yeah, hard my guys.
Well, then wouldn't.
Yo, Nick, what does a 3/6 regular 90 size in Congo?
Polygon's 9 sides, guys. You want to do,
We do 828 as well.
do you want to do 360 divided by 4?
Oh.
Sorry, 360 divided by 40.
Different D.
You want to do 360 divided by 40? Yeah, 9. That's what is 9. Yeah. Oh, no, it's not 360. Remember, we have a formula for that.
Yeah.
Remember the formula was 80 times n minus 2. Parentheses n minus 2.
360.
Right.
No. Next in.
Yeah.
Oh my god.
So what can we do?
Oh my god.
So that's the sum of all the angles, right? Nope, no, 360.
Oh my god.
I already know what I'm doing.
So this is the sum, and you have n angles. So this whole thing is divided by n. This whole thing here is divided by n.
Yeah.
Because you want to take the sum, divide by n to get the measure of each angle. Yeah, the whole thing's over. Right. Right.
Because you can
Yeah.
put stuff on here.
Yeah, let's do that. Yeah.
Oh.
So this is on because I did it all.
Good.
I would draw
Favorite angles.
You can hold up.
Not do that. Not.
18 years poly plus like 2 rings. Which has 17 years next year.
Get that.
Back, you got Birdo, wings.
What is the measure of the?
Is it before? I think it's.
It's 9. No?
Yeah, sophomores. Or sophomores. Regular events, there's 15 guys, there's 5 new spots. Wait, now, there's 2 spots. All. It makes sense. It's not like.
Waste restroom.
Why?
Okay. How many times do you guys need? Okay. All right, so our answer
I got it.
make this out.
I told you my calculator doesn't work.
Then 219.
Okay, let me show you.
But.
C is 360 divided by 4.
Yeah, but you can't assume that it's interior angles.
Yeah, you do.
Could be more.
So I'll look at the whole school.
Exterior angles are always
Still more? Yes.
One more day. Before my
Yes.
graduation.
Good. Yeah, and then I think what we were saying, how like to use like X and Y periods. Yeah, because you don't have native state periods. It's
Oh,
like,
it's very.
right.
So yeah, I started.
Okay. Cool. Good. Okay.
Well,
So
if you
yeah,
could-
so it's good. So let's make sure we check in
You can't assume.
tomorrow during. Are you going? So you're going to the AC during that? So I could pop in and just check in, make sure we make good progress. So
I do get them.
yeah, I'll take care of it.
Is you going back? Are all these collapsed? Like.
Let's see. Not part B.
You don't see that, I think.
Not D, dude. One interior, you're almost there.
Oh, what?
179. Part D, 139.
How do you do like?
You gotta divide that, see, I said you can put a formula in my suit times 180.
But perceive maybe not
The part B, part B doesn't have done yet.
9.
Well, part C,
Can't assume that it's.
actually, we don't know, actually, part C, right, we don't know, right? Right.
Wait, translation?
Yeah, actually, for part C, it's not 90, because we don't know, because it's a quadrilateral, we don't know if they're all equal.
That's
Yeah, how would you calculate?
Yeah, we don't know, right, we don't know. We don't know, it's not regular, so we're not sure.
And I drew it out here and
We
I
don't
was
know,
like.
but everything else is fine.
And I freaked out.
No.
Okay, guys, let's talk about it. You guys spend enough time thinking about it.
All
right.
Huh? 7. That's important.
All right. Here's the deal. So Gerardo drew a regular polygon that had extra angles of 40. So remember, all the extra angles after 360, and it's regular. Very important. The key phrase here is regular. You have to see that, otherwise you can't assume that. So no C didn't use the word regular. That's why we don't know. But A did. So, and because all of them after 360, all the extra angles divide by n equals 40 degrees, or just divide by 40 and get 9 sides. For part B, the sum, how many sides does it have? Now, it doesn't have to be regular, mind you. It could be 16 sides where all 16 sides are different. It doesn't matter. Like if I have a quadrilateral, it's really funny looking, kind of like this. Okay, it kind of looks like a trapezoid, but whatever. It's still going to have to 360, right? Because you have 4 sides. So if you know the sum, remember, set it equal to this formula, which is the sum of all angles of a polygon. And remember, we talked about this back in the day. Well, not back in the day, but like 10 days ago, 11 days ago. Remember, we saw a pattern. If this is n, and this is the sum of angles, (180), 360. And I think this bears repeating because I think we need to understand the formula, right? This is a linear function, right? As this goes up by 1, what does this go up by?
180.
180. Okay. Also, if I go backwards, I know it's weird, you don't have a two-sided figure. If I go backwards, if n is 2, that's going to be 0, right? If I have 1, it's going to be negative 180. If I have 0, it's going to be negative 360. So it's almost like there's a y-intercept. So what would my equation be? Y equals 180n minus 360. Factor out 180. That's why we have this formula, guys. So because I know you guys are trying to memorize. That's okay. We didn't have school for a week and a half. But as we get deeper and deeper in the spring, there's going to be other classes and other things we're working on. Some of you guys have, I don't think anyone has APs in this class, but if you did, you have that coming up. You got sports, you got Spirit Week. Spirit Week's coming up, right? There's a lot of distractions. So I want to make sure you guys understand, instead of memorize, because you memorize, you're going to forget. right? This is why the formula works the way it does, because it's like a linear function. We know when you have three sides 180, four sides 360, five sides 540. If you go backwards, you get 360. It's a linear function. So you can express the formula like that. Griff, go ahead. Because as I go backwards.
Anything below 360.
No. I'm treating it like a linear function. Let me talk to Mr. Davis. I don't know. Let me talk to him. I don't know. Let me talk to him. What I do know is that for those who are sophomores, next time you guys do SATs, they don't give you that formula. You actually do need to know it. Yeah, formula's not provided. That I know for sure. Okay, part D, she got 179. You could have done all that work, but I think it'd be much easier just to do 360 over 360. Can't do threes here. So that's each exterior angle, right? Each exterior angle is that. So you do 180 minus that. You get 179. And then the formula's right there. Again, this is like a linear function, right? But you can factor out the 180. And then if you want each interior angle, divide by number of sides, remember angles. And of course, all the exterior angles have 360. So. Yeah, so that's the rest of that page. And we're going to do one more page and you guys can work on homework. So I think I'll be true to my word that you guys should have about 20-ish minutes work on homework. Okay, of course, yeah. So B was this. That's because all the angles add to 180 times n minus 2. I'm setting equal to 2520. I'm solving for n. So you use the formula for the sum of all angles and solve for n algebraically. You could do that. Or you could divide 2520 by 180 and then add 2 afterwards. That's another way of looking at it. Okay, so let's go on to page 15. Again, we just want to talk just for a little bit about this page. Nick, I'm looking at you now. And you got stuff in your hair, by the way. A little bit, not much.
Find it the whole class.
Look at you a comb. Just a little piece of paper. It's not a big deal.
You're just telling me.
Okay. All right. So, okay, you're good now. Actually, not really. Okay, I'll help you a little bit. Can you read the opening paragraph, please? Yeah.
Several ways to the number of sides of regular polygon related to the measure of the interior and exterior angles of the polygon. These relationships can be represented in the diagram at right. How can these relationships be useful? What is the most efficient way to go from one measurement to another? This lesson will explore these questions so that you'll have a complete set of tools to analyze the angles of the regular polygon.
Okay, cool. Yeah, so we just kind of like have to be very flexible and interchangeable. Oh, I got the number of sides, I get the extra angle, I get the interior angle, whatever. So if I give you any one of these three things, you should be able to determine the other two. So you got to be very flexible. Like if I just give you the number of sides and tell you to find the sum of all the angles, that's easy. But if I give you the sum, and you have to find the number of sides, that requires a little bit extra work, right? So we just got to be very interchangeable here. So let me go back to the blank notes. So answer the questions below, and we're just going to do A through D, and then we'll be done for notes today. So if you know the number of sides of a regular polygon, how can you find the measures of an interior angle directly? So you just do this. N minus 2 times 180 all over n. That's it. So let's find the measure of each interior angle of a 15-gon. So you do 15 minus 2 times 180 over 15, because you got to find the sum first and divide by a number of sides or angles. Now, before we get too carried away, you could use a calculator if you need to, but you could also do some reduction, right? 180 and 15 are both are both multiples of what number? What number can they both be multiples of? Yeah, good. So if I do 5, that would be 36 and 3. And then can that reduce more? How's that reduce, guys? Well, 12 and 1. So you have 13 times 12 which I think is 156. Which makes sense because when you have like such a large polygon, those angles get really large. So, okay, part B. If you know the number of sides of a regular polygon, how can you find the measure of an exterior angle directly? Well, 360 over n. We just talked about it. $36 degrees. Good? Okay. Look, you want to read the next one? Part C? Yeah. I know. Say, compose yourself, dude. You got it.
What do you mean?
I know, it's hilarious, dude. That's all right, man. What if you know? Or you want to tell us how to do it? Why don't you tell us how to do it? Mhm. Okay. So what we could do is this. If each interior angle, let's say it's 162 degrees, right? There's like more going on to this, right? If that's 162 degrees, if I extend this, what's going to measure that little sliver right here? So let's measure that little guy there. No, remember they have to what? 180. What's 180 minus 162? 18.
Oh.
Yeah, you're doing 200. It's okay. So it's 18, right? So each exterior angle now the sum. What was the sum of the exterior angles again? So how many exterior angles do I got? And you got 20 sides. There you go. So now that we know all the exterior angles after 360, you don't have to get so fancy and do the n minus 2 times 180 formula. You don't need to do that. You can just do this, right? Just imagine that, oh, each interior angle is 162. Okay, then each exterior angle is 18. Okay, and I got 20, and all the exterior angles have to have 360. Okay, I just divide it. I'm good. Right. Okay. Last one, part D, and then you guys can work on homework. The measure of exterior angle is 15 degrees. How many sides does it have? Well, you do the same thing. Same thing. 360. Only 4 sides. And then each interior angle, (165 degrees). Okay. This is a good place to end for today. Okay. As for homework, so Mr. Davidson kind of did something different this class. I want to do the same what he's doing. So instead of giving you guys 2 assignments to be due Wednesday, we'll just forget about homework 14. Now, if you did homework 14, anyone actually do it? Okay, well, look at you, dude. That's good. Look, Marco and Griff, good. Okay, if you did it, that means you've already done half the homework of homework 15 then. So you'll have half left. So don't worry about 14. Look at 15. Unless you did part of 14, then your 15's less. What was that? Then look at homework 15. Any of the problems that were from homework 14 that are homework 15, you can ignore.
So
you're
don't do 14 if you didn't do it.
Correct. Don't do 14 if you didn't do it. Correct. Don't worry about it. I'll still give you credit for it. Yeah. And so homework is gonna, let me go Schoology here.
So if the people didn't do it, do they still get credit?
I'm just gonna give it blanket points for everybody, so don't worry about it. But if you did do it and somehow like you're kind of like right on that border as we get close to the end, that might give you a little extra push if you need it. But I wouldn't worry. Don't worry about it. I think Mr. Davidson already signed it for my students. Hold on a sec. Let me go to Mr. Davidson's class. Give me one sec here. That's what he did. He has 4 sections of geometry. I teach 2, so we have 6 total sections. And I teach 2 pre-calculus. So I teach all the pre-calculus honors classes and then VC honors in it. But geometry and algebra 2 are our largest sections at the school, or for the math department, because everyone's got to take those classes. So here. Okay. You guys should have the homework packet too. Remember I gave you guys a homework packet? So you can just like kind of like mix and match 14 and 15. Sorry if it's a little confusing. Yeah, it's actually not that much more. It's a little bit. Yeah, it's like 3 extra problems compared to, or 1, 2, 3, 4, 5, 6. Yeah, so come on. This will be doing the 24th for my G period, 25th. And if you're gone for a senior retreat, sophomore retreat, I mean, you could just show it to me later. Or, if you don't have it in by Wednesday, it's fine, but you might want to get it done though. And so again, you guys have the homework packet. And homework 14. Again, you're gonna do 833 and 835. So go back to homework. So if you already did homework 14, you don't have to do the first 2 problems. You already did them. But if you've not, then go back to homework 14, do 833 and 835, the last 2 questions there. And then go to homework 15, do all the circle problems in homework 15. You guys have this packet. And it's in Schoology as well, I believe. And that's your homework. So you guys can get started. You got about another 20-ish minutes. And I'll stop recording.
So, showed you